Welcome. So we are finishing this unit here on Khan Academy. This is for 7th grade statistics and probability, dealing with compound events in sample spaces and comparing and sampling populations. The beginning of this unit, simple. Now it's going to get a little trickier. So what is a sample space? A sample space is a set of all possible outcomes of an experiment. An event is the subset of the sample space. It represents a specific outcome or combination of outcomes. And they like to use capital letters. So let's look at some sample spaces here. So here they're just asking us which chart would be better to go with this experiment here. Okay, so Lucy and Katie are registering for a sports league for next year. There are two sports, volleyball and basketball. And there are 3 different seasons to choose from. So volleyball, you can do fall, winter, spring. Basketball, fall, winter, spring. Okay. This one's not correct. They said there's only these 3 seasons. Why is summer here? So only Lucy's display is correct, representing these, right? So this is pretty much showing you how you would create these. Okay, so there are 3 colors and 2 sizes. So 3 colors. Okay, what's going on here? That's a mess, right? They just put it in a different order, I guess. Yeah. Well, actually, both of those are fine because I guess the 2 sizes are small and large, small and large. So both of those are the same. They're just in different orders. So it's just going over how you should do these. All right. So let's look at this question here. If you are rolling 2 dice and they have 6 sides, what is the probability at least one dice shows a 3? And so you should make a chart, right? If I have 6 dice, my outcomes here would be out of 36. So we know that it would be out of 36. So you would make a chart, right? I would get a 1 and a 1, a 1, a 2, a 1, a 3, a 1, a 4, a 1, a 5, a 1, a 6, a 2, a 1, a 2, a 2, a 2, and then just make the chart. Okay, so what's our chances that a 3 will show here, right? All of those there. And also all of these here. So we can't count those. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait, what did it ask? What is the probability that at least one die shows? Oh, sorry, at least one die shows. Okay, so in that case, it's the ones I circled. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait, did I count wrong? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Sorry, I had originally counted one of them twice. Hold on, my mouse is acting weird. All right, so in that case, 11 out of 36 of these would work. And so that's what we would put for our answer. So you would have to make a chart and list all the possible outcomes, which can be very time consuming when dealing with probabilities of compound events. All right, let's go to the counting principle. These are simple. They're asking, how many teams can I make with all these different players? William is drafting his fantasy basketball team. He needs to select one player for each position. The following table shows how many players are available for each position. How many different teams can he make? All right, if we multiplied those together, you can see we would get 15,120 different teams he could make with just these amount of players. So pretty much for these, you're just multiplying, to find the let's go back to that formula. To find the total possible number of possible outcomes, you multiply the total possibilities, right? That only makes sense. Because when you make these charts, there will be 4,320 different options to choose from. Probability can snowball effect really quickly. All right, let's go to valid claims here. Sweet Treats Candy Company wants to introduce a new flavor of jelly bean. They have 3 different choices, mango, papaya, or coconut. They decide to do a survey to determine which flavor their customers prefer. A random sample of 100 Sweet Treats customers tried a free Sweet Treats customers tried a free sample of all 3 flavors. The data shows what they prefer. Based on this data, which the following conclusions are valid? All right, so we must see what population they tested. Okay, so they decided to do a survey to determine which flavor their customers prefer. So we can't conclude anything about the entire population, like it says here. We cannot conclude anything about the entire population, only what their customers prefer since they did a sample on their customers. So about 55% wanted mango. So we can't say, all adults prefer mango. Oh, sorry, it's this one. Prefer mango. Okay. So we can't say all adults prefer mango because we can't conclude that about the entire population unless we tested participants from the overall entire population. You could do like maybe a few from each state, a few from each city in the US, which would be a very big study. So here they just tested their customers. So we can only conclude that 55% of all sweet treats customers about, not exact. All right. So based on the data, which of the following conclusions are valid? So this, they asked all students in the senior class, do they prefer chocolate or butterscotch? And about 42% of them said chocolate. So we cannot say of all students, right? We only tested the senior class. It says 42% of male students in the senior class. It didn't say anything about looking at just the male students. So you're basically seeing, what is true based on this study. Bounce Club surveyed a random sample of 55 of their members about their favorite music type. Of the members surveyed, 22 said that jazz was their favorite, and there are 422 Bounce Club members. Based on the data, what's the most reasonable estimate for the number of Bounce Club members whose favorite type of music is jazz? So Bounce Club surveyed a random sample of 55 of the members surveyed. 22 of them liked jazz, but there's a total of 422. So let's do some cross equal proportion. Sorry, my microphone cut out. 9,284 is equal to 55x. Divide both sides by 55. And that would get me about 169. Let's see which way they did it. So they did 422 times 22. Okay, you could do it that way too. Pretty much same thing. Get the same answer. So here we're just seeing, based on this little sample size that I did, what's the estimate for this entire, population or entire middle school students? Okay, so a group randomly selected these middle school athletes to pick their favorite sport. There are 414 athletes at this school. Based on the data, how many of them like hockey? Okay, well, 10 of them like hockey. But let's see, how many did they test? They did 15 here, 9 here, 10 there. And this is a histogram. You should know how to read this from 6th grade math. This is an 8, and that's a 3. All right, so if I added all those together, 15 plus 9 plus 10 plus 8 plus 3 gets me 45. And so if I multiplied that by the number of athletes, I would get 92. About 92 of them would like hockey. Very simple. Moving on. Let's compare distributions here. And this is the last part of the unit. The Baltimore Ravens. My microphone keeps acting up today. Okay, the Baltimore Ravens won the American Football Championship in 2013. In the same season, the Kansas City Chiefs have a record of 2 wins and 14 losses. The dot plots below show the 40-yard dash times. What pieces of information can be gathered from these dot plots? The defensive backs on the Chiefs are faster on average. We would have to find the average. Being that most of it is a little up there and theirs are down there, it's going to make that a little lower. So I'm going to have to say yes. The speed of the defensive backs on the Chiefs varies noticeably more than the speed. Okay, no. I'm going to just go with A because you can see that differs a little more. Let's see. So this would be none of the above. For sure, it's not going to be this one. The defensive backs are faster on average, so I guess it helps to actually find the average. Let's see if Khan Academy actually found the average. We don't have to calculate the mean values of each distribution because we can see visually that the center of the Ravens distribution is lower. Oh, wait, did I read? Is lower than the center of the Chiefs. Since lower times are, oh, what am I thinking? I'm thinking this means they're faster, but no, that means they're slower. Sorry. This is faster. I forget when you're running, you want a very small amount of time. Okay, so yeah, none of the above. People seem to like movies about comic book heroes. The histograms show the gross revenue. What piece of information can be gathered? Movies based on Marvel heroes bring in more money on average. Okay, so this is the number of movies and the revenue made. All Marvel movies bring in more money than all of them? No, that's not true. The amount earned by DX movies varies much more. Uh, see, these are such close answers where it's tricky. I mean, without having to calculate, you're kind of just guessing here. So maybe, no, that doesn't look like it brings in more. I'm just going to go with A. So, for these, just try your best. You're not calculating anything. You're just, making an assumption, assuming, taking your best guess. So just try your best. Good luck. Let me know if you have any questions.